So this is section 6.4. This is going to be the second part of your homework where you're going to do all the guided practice for um, how to use rectangles. But this is one of the theorems that you're going to have to know about the diagonals of a rectangle. It says that if a parallelogram is a rectangle, then its diagonals are congruent. Okay, so one thing I wanted to point out here is that this says is if it's a parallelogram. So if it just says something about a quadrilateral, first prove it is a parallelogram. Okay, so first you have to prove a quadrilateral is a parallelogram, then prove that it's a rectangle, and then if it's a rectangle, then you know that the diagonals are congruent. Okay, so make sure you understand that terminology, that you have to make sure that something's a parallelogram first before you can say it's a rectangle. Okay, so then its diagonals are going to be congruent. So then JL is going to be congruent to MK. Okay, also don't forget that because this is a parallelogram, we know that those diagonals are also going to bisect each other. So, okay, let's go ahead and do a problem. So example number 1 says a rectangular garden gate is reinforced with diagonal braces to prevent it from sagging. If JK is 12 feet, so here's 12 feet, and LN is 6.5 feet, okay, find KM. So that's this entire thing. Okay, so remember diagonals are congruent in a rectangle. It says it's a rectangle here, so we're good. Okay, and also because it's a parallelogram, we know that those diagonals are going to be congruent to each other. So if LN is 6.5, okay, then JN is going to be 6.5 feet because they bisect each other. So therefore, because the diagonals are congruent, and we're going to go ahead and say that JL is equal to 13 feet, KM is also going to equal 13 feet because, of course, like the diagonals are going to be congruent since it is a rectangle. Okay, so there's how to work with diagonals and them being congruent. So we've got quadrilateral RSTU and it is a rectangle. The measure of RTU is 8x plus 4. So here's 8x plus 4. And the measure of SUR is 3x minus 2. We're trying to find x. So since this is a rectangle, okay, one thing we know are that diagonals are congruent. We know that the diagonals bisect each other because it is a rectangle, or because it's a parallelogram. And because it's also a rectangle, we know that all four corners equal 90 degrees. Okay, all angles are 90 degrees. That's the standard definition. So what I'm going to do is I'm going to just say, well, since it's a rectangle, we know that we're going to say since it is a rectangle, we know that measure of TUR equals 90 degrees. And so what we're going to try to do, if you notice that together, they don't look like they're set equal to each other, okay? They don't look like they are congruent, but notice that they kind of look like together they might equal a right angle. So we're going to try to work towards proving, that they're right angle. We can't just say, oh, they look like it. We need to actually prove it. So since it's a rectangle, the measure of angle TUR is 90 degrees. So that's this angle right here. Okay, we're going to kind of hold on to that and come back to it. So we also know that since the diagonals bisect each other, since it's a parallelogram, and also that they are congruent, the diagonals are congruent, we know that PT is going to be congruent to PU. So we're going to go ahead and say that since, oh, it changed color on me. Okay, so since this is a rectangle. Again, we're going to go ahead and just rewrite that. PT is congruent to PU. Right. The diagonals bisect each other and are congruent. Okay, so we've got PT is congruent to PU. Now notice, okay, that we now have that since these are congruent to each other, we now have an isosceles triangle here. Let me use a different color to kind of point that out. Right here is an isosceles triangle. So we know that since triangle PTU is an isosceles triangle, angle PTU, or I'm going to actually use the angles that they use in the problem. So that would be RTU is going to be congruent to angle, looks like SUT. Okay, and thus, therefore, the measure of angle RTU is going to be congruent to, or is going to be equal to, excuse me, it's going to be equal to the measure of SUT. All right, I am running out of room here, but we're going to see what we can do. Okay, so we now have that, get rid of some stuff here. Let's get rid of that. Okay, so we now have that these are congruent to each other, which is good because notice that together, okay, since RTU is going to be congruent to SUT, okay, and together SUT with SUR together, they make a 90-degree angle. So here's what we're going to do. We're going to say that we're going to try to fit this in here, that the measure of SUR plus the measure of angle SUT equals 90 degrees. Okay, but we now know that RTU is the same thing as SUT, so we're going to use substitution here. This is an angle addition postulate. I just angle addition postulate here. The measure of angle SUR plus the measure of RTU is going to be equal to 90. Okay, so just substituting here. Okay, coming from this right there. Okay, and now we're going to substitute. I'm going to see if I can have the room 3x minus 2 equals 90. And then hopefully after that, you're going to see, like you can see that we're just going to be doing some, so that's another substitution. After that's just going to be algebra, so we're going to get 11x minus 2 equals 90. And then after that goes 11x is equal to 88. So then you've got x is equal to 8. Alright, so I know it's a little bit more complicated than what it seems like, but at first, but honestly, it's just about, geometry. It's about proving. We all know and love proving things, even though things seem ridiculously obvious. But, okay, just to kind of show you how that would work and what the steps would be in order to actually prove something like this. Okay, so there's example number 2. Go. Alright, so the second theorem we're going to look at for section 6.4 is that if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Okay, notice again, it first mentions a parallelogram. Okay, so it doesn't say if the diagonals of a quadrilateral are congruent, then the quadrilateral is a rectangle. No, it says a parallelogram. So first, proving something is if it doesn't say it's a parallelogram, it just says quadrilateral. The first step is going to be proving that it's a parallelogram. Okay, so you can't forget that step. Okay, but this is kind of like the converse of the first one. Okay, so here we're saying, well, if you got a parallelogram and the diagonals are congruent, that this parallelogram must be a rectangle. All right, so we've got this canvas. Okay, so some artists stretch their own canvas over wooden frames. This allows them to customize the size of a canvas. In order to ensure that the frame is rectangular before stretching the canvas, an artist measures the sides, and the diagonals of a frame. If AB is 12 inches, so here's 12 inches, okay, and BC is 35 inches, CD is 12, and then DA is 35, and then we've got BD is 37, and we've got AC is also 37. Okay, explain how an artist can be sure that the frame is rectangular. And since there's not a whole lot of room, I'm going to go ahead and make space ready for me. So again, this is saying it was a quadrilateral. So we really need to prove that it's a parallelogram first. So hopefully you remember that in a parallelogram, the opposite sides must be congruent. And in this case, I'm going to go ahead and draw this out really quick again. We had 12, 12, 35, 35. This was 37, and then that was 37. I know it's really messy, but as long as you kind of get the gist of, what we were doing here. So we are going to say, well, first of all, since the opposite sides of the parallelogram are congruent, the quadrilateral is a parallelogram. Okay, so we've noticed that both pairs of opposite sides are congruent, so therefore this must be a parallelogram. Okay, now that we've established it's a good parallelogram, we can go into saying something about it being a rectangle. So, since the diagonals, and we know about the diagonals of a rectangle, they're congruent. Since the diagonals of this parallelogram are congruent, the canvas A is a rectangle. Okay, simple as that. Right, first proving it's a parallelogram, then proving that it's a rectangle. And the last problem that we're going to do is we have this quadrilateral JKLM, and it has the vertices J is -2, 3, K is 1, 4, L 3, -2, and M 0, -3. And we're going to determine whether JKLM is a rectangle using the distance formula. So we have a set way to do this distance formula, no other way. Because I know, again, we all love the distance formula. Right, also notice this says quadrilateral, so hopefully you remember that the very first thing that we need to do is prove that it's a parallelogram. And if we're only able to use the distance formula, we need to say something about the both pairs of opposite sides. So we're going to crank out the good old distance formula and check all four sides. So let's go ahead and do that. Let's do JK first. So JK is going to be, let's see, 1 minus a negative 2 squared plus 4 minus 3 squared. And then, so that's going to be 1 plus 2, 3. Okay, so 3 squared, 3 squared plus 1 squared is going to be equal to 9 plus 1, which is square root of 10. Okay, so there's JK. Now let's do the opposite side of JK, which is ML. So we've got 3 minus 0 squared plus negative 2 minus a negative 3 squared. So we've got 3 squared plus, and the negative 2 plus 3 is 1 squared. So 9 plus 1, 10. So far, so good. But again, we have to check the other pair. So let's do KL. We've got 3 minus 1 squared plus negative 2 minus 4 squared. So 3 minus 1, 2, 2 squared plus, it's like a negative 6 squared. So we've got 4 plus 36 equals square root of 40. All right, and then we've got JM, last one, to prove it's a parallelogram. So we've got negative 2 minus 0 squared plus 3 minus negative 3 squared. So that's going to be a negative 2 squared plus a 6 squared, which is 4 plus 36 square root of 40. Okay, so we've got both pairs of opposite sides being congruent, so therefore we can say that JKLM is a parallelogram. All right. However, we're trying to prove that JKLM is not just a parallelogram. We're trying to prove that JKLM is a rectangle. So I'm going to move on and give some more. All right, so now to prove that JKLM is a rectangle. All right, and to do that, remember, we need to prove that the diagonals are going to be congruent to each other. So just for our reference, since it's on the previous slide, we have that J is negative 2, 3, K is 1, 4, L is 3, negative 2, and M is 0, negative 3. And from the previous slide, you could also see that we had the diagonals were JL, okay, and then you also have the diagonal KN. So we need to prove that those are congruent to each other. So we're going to use distance formula. So here we go. JL is going to be 3 minus a negative 2 squared plus negative 2 minus 3 squared. So 3 plus 2 is 5 squared. 5 squared, 25. Okay, and then plus negative 2 minus 3, negative 5 squared, 25. So square root of 50. All right, now Km is going to be, we've got 0 minus 1 squared plus negative 3 minus 4 squared. So 0 minus 1, negative 1 squared, 1 squared. Hey, it changed again. Oh well. Okay, plus negative 3 minus 4, negative 7 squared. I don't like that, but oh well. Alright, so we've got, so 1 squared is 1 plus negative 7 squared, 49, square root of 50. Alright, notice that we've got, these two are equal to each other, so we can say that, yes, JKLM is a rectangle. And then we are finished. And so hopefully this helps. Go ahead, start your homework, come up with questions, and be ready to go so that we can talk about it next class.